G'day YouTube, Warbles on a lot here. I used to have a subscriber called Derived Energy. He's dead now, but before he died, he asked me to explain why I thought that bacteria or viruses might colonise other planets, but civilisations never do. And ABC Radio National is about to give us a really nice little dissertation and discussion on colonising other planets. So I thought I'd share this with you all, and I'm sorry DE, it's coming up there, but it's coming up late.
And counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition.
We choose to go to the moon in this decade and do the other thing. Not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills.
Here's a little fact that rarely gets a mention. Back in the 1960s, in the lead up to the launch of Apollo 11, public support in the United States was pretty iffy on the value of space exploration. In fact, according to the Smithsonian's National Air and Space Museum, even after Neil Armstrong put his foot on the moon, only around 53% of Americans actually thought the space program was value for money. Hello, Anthony Fennell here.
0, all engine running.
Welcome to Future Tense.
Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
And you know, that probably goes some way in explaining why the US space program has struggled since the end of the Cold War to secure government support and public enthusiasm. Now, I know I'm not supposed to give you my opinion, but I'm going to pontificate for a moment anyway and declare that a lot of recent space initiatives have been pretty, well, ho-hum. The Mars rover being an exception, of course. But really, ongoing trips to the International Space Station and Richard Branson's pseudo-space tourism, forgive me for saying this, but it all seems a bit small-scale, a bit pedestrian. So, today on Future Tense, in the second instalment in our summer series on space and spaceflight, we're going to meet some visionaries, people not afraid to think outside the square. Or the solar system, as the case may be.
We talk about 100-year Starship are going to another solar system within the next 100 years as a grand challenge. Figuring it out is a grand challenge. It means that we can no longer think just small baby steps. We have to figure out how to jump completely outside the box and view things very, very differently.
Dr. Mae Jemison knows space from the perspective of somebody who's actually floated about in it. She's a former space shuttle astronaut, and the modestly funded organisation she heads, the 100-year Starship Project, has a Herculean task to try and generate interest and enthusiasm in the notion of eventually sending humans way out into space. And not just to another planet, but as you've just heard her say, to another star system.
An African proverb goes, no one has to show a child the sky. All of us have looked up at the stars. Throughout our history, I believe space exploration, whether it's just looking up and trying to figure out what's out there, space exploration is very much a part of human history and who we are. Thousands of generations ago, somebody figured out the stars were moving relative to each other. Those lights in the heavens, right, were moving relative to each other. That was our first foray into space exploration, and we're building on it. And we've gotten support from individuals who are artists and storytellers to sociologists. We had someone who works in textile design when we did the 100-year Starship Public Symposium this past September. He came in and he talked about, well, you know, people won't think about clothing, but it's actually a serious problem we plan on going because it generates an incredible amount of waste in terms of toxins that are used to clean clothing, to the fact that people need clothes for identification. Everybody's not going to end up in that little spandex outfit you see in sci-fi. There are issues that we have to resolve, and we think about the world differently. So, you know, my biggest challenge is to keep people from trying to solve the problem and say, hey, it's going to be just like we see on Star Trek. Right? It's not necessarily going to be that way. We have to think about it a little bit differently and free our mind. As we do that, we have to think about how it's going to transform us. And it absolutely is what I call a transdisciplinary problem, because you actually are working across systems, right? It's not just at the intersection between two disciplines. It's across disciplines that you have to solve this.
Now, one of the unexpected and perhaps gratifying things about talking to those involved in exploring the potential of interstellar travel is that they openly admit they have no idea how to do it. Not yet, at least. Mae Jemison, for instance, points out that to try and travel to a nearby solar system using current technology would take astronauts more than 70,000 years. And let's face it, that would be the ultimate long-haul flight. So to be successful, the whole notion of interstellar travel will have to involve technologies that perhaps won't begin to be developed for decades. Professor Gregory Benford is a physicist at the University of California, Irvine. He's also served on the White House Council on Space Policy and been an advisor to NASA and the US Department of Energy.
A century gives you a frame that we know now, because we've seen the evolution of industrial society. The expansion of the United States into the West began roughly around 1850, and within a century was accomplished largely through railroads and use of coal for power. But it went on to new heights. We invented the airplane, and a century later, we already had intercontinental air flight commonly available. It's this kind of building upon a model that makes starflight a proper goal for the development of the interplanetary economy that we believe is coming, and therefore sets a goal. 100 years from now, let's see if we can build a starship, and what does it look like? And is it manned or unmanned or robotic, or does it have an artificial intelligence aboard? Those are secondary issues. The main thing is, let's have a goal, and let's build toward it.
It's a curious thing, though, isn't it, about our age at the moment, that even though we've become much more sophisticated with our technology and our systems, we don't seem to be long-term thinkers. And one of the criticisms that's often made of our society today is that we're very short-term in our thinking and getting worse.
Short-term thinking comes from essentially closed-in thinking that comes from living in an already defined environment. We've essentially explored the entire planet, and there are a few mysteries left, perhaps the deep sea. But the entire solar system beckons beyond, and not only is that a terrifically interesting place to explore, but future human prosperity will rely upon those resources. Where are we going to get the metals and many, many other things like helium-3 that you will need in fusion reactors? Because we know we don't have enough on the surface of the Earth. We're going to have to go elsewhere to get the materials we need. And that will also expand greatly the human prospect, because these will inevitably harbor fresh human societies and new human ideas, new politics, new societies. Everything will change, driven by the goal of building an interplanetary economy.
There is still a mindset issue, though, isn't there? Getting people to take interstellar space travel seriously, to get them to understand that there is a potential there that is more than just science fiction.
Yes, starflight is a very, very big, hard problem. But so was winged flight through the atmosphere 200 years ago, or even 100 years ago. You could do it with balloons, but you couldn't control it. So the whole point about thinking about the future is to have some concrete goal in mind and then discover a pathway that leads that way. And what we've learned from prior human history is that prosperity comes from these steps, because you're building a structure every step of the way.
Now, at this point, you've probably got the idea that there are quite a few very reputable people about with a passion for interstellar flight, even if it isn't yet anywhere near the top of the priority list for the US government, or any other government for that matter, or even on a priority list at all. So, the question to explore then is one of motivation. Why should we as a species want to journey to planets outside our solar system? Well, it seems to me there are three main reasons expressed. Firstly, there are those people who see the need for interstellar travel because they believe we have to start planning for the time when planet Earth no longer exists. So in a sense, we need to start spreading our eggs into more than one basket. The second motivation relates to resources. Remember what Gregory Benford said?
Where are we going to get the metals and many, many other things like helium-3 that you will need in fusion reactors, because we know we don't have enough on the surface of the Earth, we're going to have to go elsewhere to get the materials we need.
So that's what I would roughly term the future resources motivation. And the third motivation I've determined relates to curiosity. Given what we're now beginning to learn about the world outside our solar system because of advances in astronomy, will we be able to resist the temptation to go and explore? On that point, let's hear now from Professor Ian Crawford at the University of London, a former member of both the Human Spaceflight Vision Group, established by the European Space Agency, and also the UK Space Exploration Working Group. Ian Crawford.
The ostensible reason, I think, at least in the early stages, can only be scientific. It's far too premature to start thinking of colonising planets around other stars. I mean, the chance that we would find a planet around a nearby star on which human beings could just land and start living on, I mean, it's zero, basically. It's just that, I think it's absolutely out of the question we would find another planet habitable for human beings. On the other hand, we may well find planets around nearby stars that are inhabited by their own life forms that have evolved to live in very different alien environments. And scientifically, there's been enormous interest in studying those. My suspicion is the way this will get started is we've already started discovering planets around other stars, right? Since 1995, we've now found over 800 planets orbiting other stars. And then we've had the report that the nearest stars, one of the three nearest stars, Alpha Centauri B, has a planet. And so we're finding nearby planets. And now we know that probably is a planetary system around the nearest star. So that's 4 light years away. And that's still a long way to go. But if in the next few decades astronomers find that there are planets around Alpha Centauri or some other nearby star which seem to be inhabited, and you'd learn that by looking at the composition of their atmosphere through spectroscopy, using telescopes to measure the composition of their atmospheres. I think if we found there was evidence for an inhabited planet, then that would really focus people's interest. It would gather a lot of scientific interest. It would gather a lot of public interest. And I think that's the kind of thing that would start the ball rolling. Maybe it's already rolling, but would speed the ball rolling up a bit faster towards interstellar spaceflight. But that interest could only be scientific. I mean, there's no possibility at all, realistically, of finding a planet that human beings could just emigrate to. So I think it's not too soon to start thinking along those lines. But the technology to build an interstellar space probe that could get to a nearby planet around a nearby star in anything short of 100 years travel time is really very, very ambitious.
If I can just touch on that or just focus on that a bit more, what are we talking about in terms of distances? For the average person, it's just a long, long way away.
It depends on how fast you go. So Alpha Centauri is the nearest star. It's a triple star system. That's 3 components, Alpha Centauri A, B, and C. Obviously, in Australia, it's fantastically one of the brightest stars in the southern sky. So most of your listeners will be familiar with Alpha Centauri, I hope. And it's so bright because it's one of the closest stars, and it's only, in inverted commas, 4 light years away. So that means it takes light travelling at the speed of light 4 years, actually 4.5 years almost, 4.4 years to make that journey. So that means if you could build a space probe that would travel at the speed of light, which we can't, but if we could, it would take 4 years. People who think about interstellar space travel, recognising that we'll probably never be able to build anything that could travel that fast, tend to assume that we could build rockets or space vehicles that might travel at, say, 10% of the speed of light. So that's far faster than anything we can do yet, but it's not physically impossible to envisage something that could travel at a tenth of the speed of light, and that would take 40 years. So many decades travel time, yes. If you could travel at only 5% of the speed of light, then you're getting on for 100 years. So really, how long it takes to get there depends on how fast you go, and it's unlikely to be quicker than many decades to a few centuries, and that's just set by the scale of the universe and our engineering limitations, really. So society will have to reconcile itself to travel times of many decades, at least, in order to send the space probe to even the nearest star.
You're with Future Tense. New ideas, new approaches, new technologies. We're available as a podcast via iTunes and ABC Online, and our name on Twitter is RN Future Tense, all one word.
15.
Igniters armed.
Rough ignition.
This is Delta Mission Control at T-minus 10, 9, 8, 7, 6, 5, 4, 3. And the RS-68A engines roar to life and liftoff of the United Launch Alliance Delta IV Heavy, carrying the NRO L-15 mission for the National Reconnaissance Office.
We're a clever lot, really. In just a few decades, we've made incredible advances in rocket technology. But as we've heard, the truth is that conventional rockets are never going to give us the speed we'll need to reach another star system. Now, as already mentioned, those involved in the interstellar field believe a viable alternative form of propulsion may still be some way off. But that hasn't stopped them looking at the potential of some existing sources of power. Dr. Richard Obusi is the president of Project Icarus, and it's dedicated to investigating the potential of thermonuclear fusion as a way of powering a future starship. I asked Dr. Obusi why they'd zeroed in on that particular power source.
The main reason is that Project Icarus is the successor study to Project Daedalus, which was a project that ran from 1973 to 1978. It was conducted by the British Interplanetary Society, and what they came up with was an interstellar starship design based on ICF, or inertial confinement fusion. And when there were early discussions on essentially doing the successor mission to Project Daedalus, 30 years on, almost 30 years on, we felt that there needed to be some continuity because it had that association and that heritage. We felt that there needed to be continuity. So we laser focused down onto looking at fusion. But there are a number of other techniques that one could analyze. There's good reason to believe that that's one of the more likely approaches to interstellar flight.
And it has a credibility, doesn't it? Because it is a form of technology that we are familiar with, at least, that is known.
Yes, I'm glad you reminded me of that as well, and you're absolutely correct. I mean, as you know, there are two forms of nuclear energy. There's nuclear fission and nuclear fusion. We know both work. We've, to all intents and purposes, mastered nuclear fission. We have liberated energy from thermonuclear fusion, but not in the controlled method that scientists are working toward. But we know that it works. You just look up at our sun during the day to know that thermonuclear fusion works and it liberates vast amounts of energy. So exactly, there's credibility associated with it.
Now, my understanding is that the construction of an interstellar spacecraft would have to...
Here marks the end of part 1.